Welcome back, friends. Welcome back to my channel Universal Digital Audios Bangalore. In today's video, we will learn how to build power supply for any amplifiers. So many people have called me from north side and they have requested me to make a video that how to build power supply for amplifiers. So let us go. So for any amplifiers, the first thing actually what is required is a transformer. So let me draw a transformer. See, this is the transformer and this is the core, what we says, and this is called primary. This is called primary and this is secondary. So primary will be 230 volts and secondary, it depends on the voltage it requires by you. So you will have different voltages in secondaries like 12, 0, 12, 20, 0, 20, 24, 0, 24, 28, 0, 28, 30, 0, 30, 35, 0, 35. So this goes on like this. And along with this, actually, see, if you have only voltage, so this is not sufficient. So along with that, you have to have a amperage also. So what is the amperage? 12, 0, 12. It starts from 500 milliamps. 750 milliamps, 1 amps, 2 amps, 3 amps, 5 amps, 10 amps, 15 amps. So it goes on like this. So for any amplifiers, the main voltage what is required is these voltages, and the amperage depends on the output power amplifier what you are using. So that depends on the current. So what current it requires, so that you have to think of it first. So what is the current it's required, how many wattage amplifier you are going to make, so what is the transformer is required. So that in next video actually how to calculate current and what is the current it requires for the power amplifiers, so all that I'll disclose it. So now, so this is the secondary. So in secondary, so let us say this is a 0 and let us say this is 20 volts and this is 20 volts. So you have 3 tapping here. This is 20 volts and center, if you take this, it is a 0 volt and this side end it is a 20 volts. So usually the people are designing the power supply will start with 20 volts, so that is 20 volts with 5 amps. So we'll design. So along with this, actually you will be requiring an additional tapping. So this is 0 volt and this is 230 volt. So this will be 12 0 12 volt, maybe 1.5 amps, and this is 12 volt 0 12 volt. So this is also, let us say it is 1.5 amps. So this is the transformer for the power supply. So after this, actually, so now this is a AC. Now this will give you AC output, 20 volts AC alternative current, 0 volt 20 volts AC, and this is also AC. So when you have AC, you have to convert this into DC. So any amplifiers, if you are designing, it needs DC current. So what is DC current? AC is an alternative current, and DC is a direct current. So the power supply what you have to design for the amplifiers, it is DC, direct current. So to convert this into DC, what we have to do? So you have to have a rectifier. So let us connect this. So this one is connected. This is cathode and anode. Anode, cathode. So that 20 you will be connecting here, and again 20 volts AC, 20 volts AC. So this is actually a diode. So from this diode, this is called bridge rectifier. When you use 4 diodes and make a bridge here, this is called bridge rectifier. And now types of rectifiers is a bridge rectifier, and you have 2 diodes used here. With a center tapping, 1 2 3. This will be a ground, and this is AC, and this is AC, and this is your positive, and this is your negative, I can say. So along with this, you have a filter capacitor. So this will be connected here. So this is called full wave rectifier. And if you use single diode, this is called AC ground. Half wave. Half wave rectifier. So let us go here, and this is your positive, and this is your minus, negative, and this is your ground. So here you will need one capacitor. So when you are using positive here, take this capacitor like this, connect it. So when for negative, so this is your negative and positive will be connected here to the ground. So this is called plus VCC, and this is GND ground, and this is minus VCC. So I'll describe all this: what is plus VCC, what is minus VCC, what is VE, VCE. All this I'll describe in next video. So let us understand this one. So from the 20 we'll be connecting one end here, the other end here, and the common ground is here. This is called 0 volt. So this is the power supply what you have to design. So from here you can take. So if it is a 20 volts, if you are feeding here, so almost 1.5 times more capacitor you are supposed to use here. For example, 4735 volts. This is also 4735 volts. You can use capacitor. So this is 0 volt plus minus. So this is called dual supply. This is called dual supply. So here also same thing. From the other tap 12012, you are connecting one end here, the other end 0 here, and the other end AC here 20 0 20. You are connecting it here. And the same way the ground will be connected here. This is 0 volt. So this became a single supply. You can make dual supply also the same way if you connect here. So this becomes a dual supply. For that you need to add an additional 2 diodes here. So this is it. So this is a single wave, half wave rectifier, full wave rectifier, and bridge rectifier. Half wave rectifier can be used for fan. If you have 12 volt 012, so the other tapping what I have shown here 012, so this can be used for this. There only one single diode is enough. So this can be connected to fan plus 12 volt. So when you are feeding 12 0 here, so it becomes 17 volt, and this is your 0 volt. Usually for fan actually you have to use a regulator. So many people have asked me like when we are connecting in the fan, it is making noise. To overcome that problem, actually I'll give you some separate circuit for fan. So that in my next video I'll describe about it. So this is it. So this is the power supply what you have to design for the amplifiers. So in my next video I will explain you about regulated power supplies. So how to distribute a power supply from here to the power amp, preamp sections, and pro logic board. So the power distribution I will be describing in my next video. Thank you friends.